kids, how are you? Welcome to today's chemistry class, and today we'll do elements, compound and mixtures. Concept to know in this chapter: introduction, elements, compound, mixture, compound and mixture, and comparative study. Preference of the particular technique over another. First is introduction. First we'll know what the matters are. We find various objects like clothes, utensils, food item, books, water, gases, etc. around us. They are all examples of matter. So all the things around us like clothes, table, chair, food item, all these are matter. They all are example of matter because all of them occupy space and have mass. So our body is also made up of matters. So everything that have mass and occupy space is matter. Do you know? Heat, light, sound and radio wave, they are not matter. Why? Because they do not have any mass and do not occupy space. So they are not considered as matter. Next is classification of matter. Matter are further classified based on their physical property and chemical property. Matter can be classified into two ways. On the basis of physical state, they are classified as solid, liquid and gases. And on the basis of chemical constitution, matters can be classified as element, compound and mixture. Elements and compounds are considered as pure substance, but mixture are considered as impure substance. So here it is a flow chart. Matter are classified into living and non-living. Again, the non-living matter is classified into pure substance and impure substance. Pure substance are further classified into elements and compound. Elements are classified into metals, non-metal, metalloid and noble gases, and impure substance classified into mixture. So first is element. The element is the pure substance which is made up of one kind of atom only. So elements are the pure substance which is made up of only one kind of atom. Clear? Like oxygen element or nitrogen element. So these are the elements. An element cannot be broken into two or more simpler substances. So element ko we cannot break into simpler substance any further by any physical or chemical method. Example: iron powder, sulfur powder, zinc granules, copper, oxygen, etc. All these are the examples of element. All of them are element. Why? Because although they are different from one another in their physical appearance, but all of them are made up of identical atom. Like iron hai, so all atoms would be of iron. So these are the element. Like iron powder, sulfur powder, zinc granules, all these are examples of element. There are total 118 elements known at present. Out of them, 94 elements occur naturally on the Earth's surface, whereas the remaining 24 elements have been prepared artificially by scientists. So total number of elements known are 118. Out of that, 94 elements occur naturally and 24 elements prepared artificially by scientists. Next is basic unit of element, that is atom. So what atom is? Atom is the smallest particle of an element which may or may not exist on its own. An atom further divisible into nucleus and orbit. So here this is an atom. It is further divisible into nucleus. So nucleus, the center of an atom that contains proton, positive charge particle and neutron particle carrying no charge. So in the nucleus, they contain proton and neutron. Proton are positively charged particle and electrons are neutral charge. They do not have any charge on it. Next is orbit. Orbits surround the nucleus in which negatively charged particle electrons revolves. So these are the orbits. In the orbit, the negatively charged particle, that called electron, they revolve around it. Clear? Next is symbol of elements. An atom is an element is denoted by a symbol. A symbol is the short form or abbreviation name of the element. A symbol distinguishes one element from another element. A symbol is the characteristic feature of an element. So every element have its own symbol so that we can identify it. Do you know? Oxygen is the most abundant element, means सबसे ज़्यादा amount पे पाया जाता है. That is 46.5% by the weight on the earth crust, followed by the silicon, that is 28.0%, and aluminum, that is 8.1%. Iron is present in the hemoglobin, the pigment in the blood. So iron is present in the hemoglobin, that is a pigment that present in our blood that give it red color. Magnesium is present in chlorophyll in plants. Next is representation of symbol. To identify each element, we have given them a symbol so that we can identify them easily. So John Dalton in 1817 suggested a figurative symbol for the atoms of element. So John Dalton, he has suggested a figurative symbol like this symbol is for hydrogen, this is for nitrogen, oxygen, phosphorus and sulfur and many more. This method was discarded. Why? Because it was tedious and not practical. It is very difficult to learn all these symbols and remember them. So Berzelius in 1840 suggested the representation of element with the symbol figure 2.5, first letter of the name of element, like hydrogen. First letter is H, so symbol is H. Carbon, first letter is C, symbol is C. For sulfur, it's S. But the method not approved completely, since two elements can have the same first letter, like carbon and calcium, both start with C. So representation of element by the first two letter of the name of element, like for calcium, Ca, aluminum, Al, and cobalt, Co. Method approved, since the large number of symbols could be written in this manner. Representation of element by deriving symbol from their Latin name. So some of element, the symbol is derived from their Latin name. For copper, the Latin name is coprum. So Cu is the symbol for copper. For sodium, its Latin name is natrum. So the symbol is Na. Pb means lead. So Cu for copper, Na for sodium and Pb for lead. Method approved, since symbols derived from Latin names are widely used. Here is a table of symbol of some metallic element with their Latin name. So this is a table. Here the name of metal is given, their atomic symbols like given here, and their Latin name is given here, like potassium, K, and the Latin name is Kalium, that's why start with K. Sodium, Na, calcium, Ca, magnesium, Mg, aluminum, Al, zinc, Zn, iron, Fe, lead, Pb, copper, Cu, mercury, Hg, silver, Ag, platinum, Pt, gold, Au. So the symbol of elements sometimes start with the first letter of that element, and sometimes it is derived from their Latin names. Next, classification of element. Elements are classified into metal, non-metal, metalloid and noble gases. So on the basis of their properties, metals and non-metal can be differentiated like metal. They are lustrous, they have shine like gold. Non-metal, they do not have luster or shine, they are non-lustrous, For example, sulfur does not have shine. Sulfur is a non-metal, but iodine is exception here. Next, metals are malleable. Malleable means they can be beaten into sheets. Like aluminum can be beaten into sheet, like aluminum foil we use, or gold is also can be beaten into the thin sheet. So, metals are malleable. Non-metal, they are non-malleable. They cannot be beaten into sheet, like carbon cannot be beaten into sheet. Next, metals are ductile. They can be drawn into wires, like copper wires, that is used in electric equipments. Non-metal, they are non-ductile, cannot be drawn into wires, like phosphorus. Metals are good conductor of heat and electricity, like copper, that is good conductor of heat and electricity. We used it to make utensils also. Non-metals are non-conductor of heat and electricity. Graphite is an exception because graphite is a conductor of electricity. Carbon is a non-metal, it is poor conductor of heat. Clear? Next, metalloid. Some element which show properties of both metal and non-metal are called metalloid. For example, boron, silicon, these are metalloids. Noble gases. Unreactive inert element present in the trace of air. They are noble gases, like helium, neon and argon. Next is periodic table. Till date, 100 elements have been discovered so far. The systematic and simple arrangement of these elements was needed at the time of its discovery. The arrangement of elements was done in the form of table called periodic table. So, all the elements are arranged according to their properties in a table. That table is called periodic table. The elements in the periodic tables are arranged in their atomic number. So, the elements are arranged according to their atomic number in periodic table. Atomic number of an element is the number of proton or electron, as both are equal in an atom of element. So, atomic number is what? Is the number of proton and electron, because both are same. Proton are positively charged and electron are negatively charged. For example, hydrogen atom has 1 electron. So that the atomic number is 1, it has placed first in the periodic table. Hydrogen atomic number is 1, so it is placed first in the periodic table. Element in the periodic tables are arranged in horizontal row like this. That is called period, and the vertical column, that is called groups. So, these are the periods: first period, second period, third period, fourth period, and these are the groups like this. Clear? So, this is the periodic table. All elements in the same group have similar chemical properties. So, all the elements which are in same group have similar chemical properties. All non-metal elements are placed on the right of the periodic table. So, non-element are placed on the right side of periodic table. For example, nitrogen, oxygen, fluorine, all these are non-metal. All metallic elements are placed on the left of the periodic table, like lithium, sodium, magnesium. So, all these are placed on the right side of periodic table. Noble gases are placed at the extreme right of the periodic table, like here. Helium, neon, argon, all these are noble gases or inert gases. Here, name of some metal, metalloid, non-metal and noble gases. Metals like lithium, beryllium, sodium, magnesium, potassium and calcium. Metalloids which show the properties of both metal and non-metal. Example, boron and silicon, non-metals. Carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine. Noble gases, helium, neon and argon. Next is name, symbols and atomic number of the first 20 elements. So, here the name, the symbol and the atomic numbers of first 20 elements is given in this table. So you have to learn this table. Here again, the name of element, their symbol and atomic number is given here. So learn this table properly. Next is molecules. Atom of the same element or different element combine to form molecule. When atom combine chemically, they form molecule. It could be of same element or different element. Molecules is the similar unit of the particle of the substance which can exist independently and can have a physical and chemical properties of that substance. First, atom of the same element forming a molecule. Atomically is the number of the atom present in one molecule of the element. Diatomic molecules means like hydrogen, H2. So, 2 atom of hydrogen. So, they are called diatomic, like nitrogen, N2, diatomic, 2 atoms. Oxygen, these are diatomic. Atomicity क्या होता है? Is the number of atom present in the molecule of element. Polyatomic means more than 2, like ozone, O3, phosphorus, P4. So, here are the molecule of same element, like hydrogen molecule. It constitutes of same element, hydrogen only 2 mole. It make hydrogen molecule 2 elements of hydrogen. Oxygen, O2, only oxygen element is present there. Nitrogen molecule, this is phosphorus molecule. So, diatomic means 2 atoms, polyatomic means more than 2 atoms. Clear? Next is check your progress. In this segment, whatever you have studied so far, the question based on that is given. So, this you have to do yourself. Next, compounds. A compound is a pure substance made up of 2 or more elements chemically combined in the fixed proportion. For example, carbon dioxide gas is made up of 2 elements, carbon and oxygen, like here. Element of carbon and element of oxygen combined in fixed proportion make carbon dioxide. It have 1 element of carbon and 2 element of oxygen. So, carbon dioxide gas is made up of 2 elements, that is carbon and oxygen. They will chemically combine in fixed proportion. In carbon dioxide, the proportion will always be fixed, like 1 atom of carbon and 2 atom of oxygen. Next is characteristic of compounds. Element in compound are present in definite proportion. It is pure and homogeneous. So, 2 atom of hydrogen and 1 atom of oxygen combine together and make H2O, means water, 1 molecule of water. So, they will always combine in fixed proportion. In water, there will be always 2 atom of hydrogen and 1 atom of oxygen. Clear? Like 1 atom of nitrogen and 2 atom of oxygen combined and make nitrogen dioxide, NO2. Clear? Compounds have properties entirely different from the properties of the element from which they are made. For example, hydrogen and oxygen are the gases, but water is a liquid. So, when hydrogen and oxygen combine and make water, the properties of water is entirely different from the hydrogen and oxygen. Here, hydrogen and oxygen are gases, but water is what? Liquid. Element in a compound cannot be separated by physical method. Like here, element of iron and element of sulfur combine together and make a compound iron sulfide. We cannot separate iron and sulfur by physical method. Iron cannot be separated from the compound iron sulfide using a magnet. Clear? Next, comparison between elements and compound. Here a table is given to you. We can compare between element and compound. Element made up of one kind of atom only. Compound, they are made up of two or more kind of atom. Element cannot be broken down into simpler substance by physical or chemical method, but the compound can be broken into simpler substance by chemical method. Element, they have their own set of properties, but the compound, the property is different from their element. Clear? Next is chemical formula. Chemical formula is a symbolic representation of one molecule of an element or the compound representing the number of atoms of that element of various elements present in it, called the formula of compound. So, in chemical formula, what we write? One molecule of an element or the compound representing the number of atoms. How many number of atoms present in that element or various element? For example, the formula of chlorine molecule is Cl2. It represents that two atoms of chlorine combine to form the molecule of chlorine. Clear? So, here two atoms of chlorine combine to make chlorine. The formula of the carbon dioxide is CO2. It represents that one atom of carbon and two atoms of oxygen combine to form the molecule of carbon dioxide. So, the chemical formula is CO2 for carbon dioxide. O2 and 2O are not the same because O2 क्या represent कर रहा है? That represent one molecule of oxygen, but 2O represent the two atom of oxygen. O2 that represent one molecule of oxygen, but 2O is different because it represents two atom of oxygen. Clear? Next is writing a chemical formula of compound. For writing a chemical formula, the symbol of element and their combining capacity of valency should be known. Whenever we write the chemical formula of any compound, we should know their symbol and their valency. The combining capacity of an atom of an element is called valency. It is in whole number. For example, the valency of hydrogen, sodium and potassium is 1. The valency of magnesium, zinc and oxygen is 2. The valency of inert gases is 0. Note. The valency of all metal is considered positive and the valency of all non-metal is considered negative. So, all the metal have positive valency and the non-metal have negative valency. Next is a table given which show the valency of some element and radicals. Here, the metallic element, all the metallic element have positive valency, like K means potassium had +1, sodium +1, Ca +2, Zn +2. Okay. 3 valency, that is Al means aluminum, non-metallic element like chlorine -1, radicals like NO3. So, -1, OH -1, O -2, S -2, radicals like SO4. It have -2 valency and CO3, it also have -2 valency. So, whenever you write the chemical formula, you should know the valency. To write a chemical formula, following steps are involved. Write the symbols of the constituent element. Write the valency of each element below their symbol. If the valency are divisible by any common factor, then divide them. When the valencies are not divisible, then leave them as they are. Now, interchanging the valency, write as script next to the symbol. Like here, we have to combine sodium and chlorine. So, Na, that is a metal, it have +1 valency. Chlorine, non-metal, -1 valency. So, what will do? Interchange the valency. Here 1 and here 1. So, दोनों की 1 है. So, ignore 1. So, chemical formula is NaCl. Like here, zinc and chlorine. Zinc is a metal, it have +2 valency and chlorine -2. So, whenever there is one valency, we will avoid that or ignore that. So, interchange it. So, Zn 1 and Cl2, 2 इधर शिफ्ट हो जाएगी and 1 इधर, so ZnCl2, zinc chloride. That is the chemical formula. This is how we'll write the chemical formula of compound. Next is mixtures. As we know, mixtures are an impure substance which is made up of two or more element or compound or both mixed together mechanically in any proportion. Mixture impure substance होते हैं. For example, when we mix sugar and water, we find that becomes sweet in taste. Sugar syrup is an example of mixture. Sodium chloride is added to water to form salt solution. Sodium chloride means common salt, table salt, that is known as sodium chloride. So solution which is an example of mixture. When the salt is added into water, it becomes a mixture. It is also a mixture of several gases, although the percentage of various gases in air is approximately known, but they are not present in any fixed ratio at all places. Next, type of mixture. Mixtures are of two types. First is homogeneous mixture. Homo means same. Mixture which have the same composition and properties throughout the mixture. For example, salt and water, sugar and water, alcohol and water. These are the example of homogeneous mixture. They all form miscible mixture. Miscible means mix हो जाते हैं. Next is heterogeneous mixture. Mixture which are different composition and properties throughout the mixture, like oil and water, chalk and water, and sand and water. They are example of heterogeneous mixture. They all form immiscible mixture, means they do not mix in each other. They make a separate layer. So these are example of homogeneous mixture. Next is characteristic of mixture. Components in a mixture are present in indefinite proportion. They do not combine chemically. Like here, element of sulfur, element of carbon and compound potassium nitrate. So, we'll mix together and make a mixture. That mixture is of gunpowder. This constituent or components, elements or compounds retain their properties. So, in the mixture, the properties of sulfur, carbon and potassium nitrate, that will retain. उसकी properties वैसी ही रहेगी. Like here, the element of iron, properties in element iron react with the hydrochloric acid. Okay. Here the element of sulfur, property is in element sulfur dissolve in solvent acetone. Sulfur acetone में dissolve हो जाएगा. So mixture will get is iron and sulfur, and properties in mixture, iron react with hydrochloric acid, same property, and the sulfur dissolve in acetone. Clear? The two properties of each element are retained in the mixture of iron and sulfur. Component in the mixture can be separated by physical means. In a mixture, we can separate the component by physical means. Like here, the element iron and element sulfur, they mix together, make a mixture of iron and sulfur. So here we can separate the iron from the sulfur by using a magnet. Clear? The mixture of two elements, iron and sulfur, can be separated by using a magnet. That is a physical method, since iron is attracted to the magnet. Next is activity. The aim of this activity is to show the difference between a mixture and a compound. Take some powder mixture of iron filling and crystal of sulfur on a piece of paper. So first we'll take a mixture, we'll make a mixture of iron filling and crystal of sulfur on the piece of paper. Observe the mixture under the magnifying glass. You will find a yellow particle of sulfur lying separately from the greyish black particle, that is iron, in the mixture. Bring the magnet over the powder mixture on the paper. Iron filling are readily attracted toward the magnet, leaving behind the sulfur on the paper. So first we'll make the mixture of iron and sulfur crystal. So when we'll bring magnet toward it, it will attract the iron filling and the sulfur will leave behind. This is the mixture. Next, take some water in a beaker and transfer the mixture of powder iron filling as sulfur into it and stir the contents. Next, we will transfer into water and stir it. Allow it to strain for some time. The sulfur come upward and float on water, but the iron filling that sink and settle down at the bottom. Again, take the powdered mixture of sulfur and iron filling in the hard glass test tube and heat it on Bunsen burner flame. The mixture become red hot and begin to glow because both combine chemically to form the dark grey compound that is iron sulfide. When we heat the mixture, it combine chemically and form new compound that is iron sulfide. Transfer the grey substance on the piece of paper and observe under the magnifying glass. Now you cannot see the particles separately. Clear? Furthermore, iron does not attract toward the magnet. Now, if we bring the magnet near it, it will not attract the iron because they chemically combine and form a new compound. Clear? So, what is the conclusion? Above activities show that the powder sulfur and iron filling is an example of mixture, but upon heating they form a new substance that is called iron sulfide. It is entirely different from the properties of its constituent, that is iron and sulfur, so that it is an example of compound. Clear?
Activity 1. Aim to show the difference between a mixture and compound. Take some powdered mixture of iron fillings and crystals of sulfur on a piece of paper. Observe the mixture under a magnifying glass. You will find yellow particles of sulfur lying separately from the greyish-black particles of iron in the mixture. Bring a magnet over the powdered mixture on the paper. Iron fillings are readily attracted towards the magnet, leaving behind the sulfur on the paper. Figure 2.7. Take some water in a beaker and transfer the mixture of powdered iron fillings and sulfur into it and stir the contents. Allow it to stand for some time. Sulfur comes upward and floats on water. Iron fillings sink and settle down at the bottom as shown in figure 2.8a. Again, take the powdered mixture of sulfur and iron fillings in a hard glass test tube and heat it on a Bunsen's burner flame. The mixture becomes red hot and begins to glow because both combine chemically to form dark grey compound, that is iron sulfide. Transfer the grey substance on a piece of paper and observe under a magnifying glass. No particles of them are seen separately. Furthermore, iron does not attract towards the magnet. Figure 2.8b. Conclusion. Above activity shows that powdered sulfur and iron fillings is an example of mixture, but upon heating, they form a new substance called iron sulfide. It has entirely different properties from its constituents, so that it is an example of a compound.
Next, compound and mixture, the comparative study. Here, we can differentiate between compound and mixture. First, on the basis of their composition. In compounds, they are present in fixed proportion. Clear? But mixture, the component are present in variable proportion. In compound, the proportion will be fixed, but mixture में कोई fixed proportion नहीं होता. Next is properties. Component do not retain their original property, but mixture, they retain their original property. Separation, we cannot separate compound by physical method, but we can separate the mixture by physical method like magnetic separation or evaporation. Energy change, during the compound form, energy is usually given out and absorbed in the preparation of compound, but in mixture, energy is neither evolved nor absorbed in the preparation of mixture. Clear? So that is the difference between compound and mixture. Here some questions are given based on whatever we have studied so far. So this you have to do yourself. Next is separation of mixtures. In this segment, we will read how the constituent or mixture can be separated. The constituent present in the mixture can be separated by physical method. For example, common salt is separated from the sea water by evaporation. Reason for separation of mixture. First is to remove unwanted substance from the mixture. For example, the mixture which contained rice and small stones and husk. So rice is a useful component and small stone and husk is unwanted component. Like grain particle or pulses, small stone are mixed with them. They are unwanted component. So we will separate them from mixture to get the useful component. Clear? Next, to obtain useful component. For example, petrol, diesel, kerosene and LPG is obtained from the crude petroleum. So that's why they are separated from their mixture. To obtain the pure substance from the mixture of pure and impure substance. For example, separating dissolved salt and the tap water by distillation. Next is method of separation. Common method used for separating mixture are discussed below. Solid-solid mixture. If the mixture contain only solids, by hand picking, sieving, magnetic separation, and fourth is sublimation. So next is solid liquid mixture. So we can separate them by filtration, sedimentation, decantation and evaporation. Next, method of separating of solid-solid mixture. First is hand picking. Hand picking, the principle of separation is based upon the size, color and shape of the solid particle. Because two solids, they will have different size, color and shape. So we can separate them by simply hand picking. The undesirable components which differ from the desirable component in size, color and hand picked and removed. For example, hand picking of small stone from the grain particle like pulses, rice, etc. So this method is known as hand picking. Next is sieving. Sieving, this method is based on sieving of different size of solid particle. In sieving, the size of particle will be different. The large size particle are separated from the smaller one by passing the mixture through a sieve, so that the large particle that retain above the sieve and the smaller particle that pass through the holes of the sieve and we can separate them. These are collected in the vessel kept below. For example, separation of barn of wheat flour, separation of stone from the pebble from sand. Like here, sieving of flour to separate the wheat bran and fine flours. Clear? So we'll sieve them and the fine flour that will come down and the coarse flour will be on the sieve. So this method, like here, sieve being used to separate the stone and pebbles from the sand. So we'll sieve them, the sand will come down and the coarse pebble and stone will be separated from it. Clear? Next, magnetic separation. Magnetic separation is based on the difference in magnetic and non-magnetic nature of particle. The magnetic particles such as iron are separated from the non-magnetic particles such as wood, plastic, etc. by using the magnetic nature of iron. The iron metal that get attracted to the magnet and non-magnetic substance are left behind. So when we bring the magnet near that mixture, the iron metal get attracted to the magnet and non-magnetic substance are left behind. For example, electromagnet fitted on the cranes pick up iron particles from unwanted waste material like plastic, glass, paper. Separation of iron from the iron sulfur mixture, that is also based on this principle. So by this method we can separate two magnetic and non-magnetic substance. Clear? Next is sublimation. The process in which the solid directly change into gaseous state without changing into liquid state on heating is called sublimation. Sublimation is what? Sublimation is the process when the solid directly changes into gases without changing into liquid. That is called sublimation. For the example, substances like iodine, ammonium chloride, naphthalene and camphor, etc. All these are example of sublimation. Sublimation method is based on the difference of sublimable and non-sublimable nature of solid. Those solid substances which directly change into vapor on heating without passing through the liquid state are called sublimable solids. The vapor on cooling give back the pure solid. The sublimable solid on heating with the non-sublimable substance undergoes sublimation. The vapor of the sublimable substance condenses in its pure form in the inner side of the funnel, whereas the non-sublimable solid remain behind the evaporating dish. The function of the cotton plug is to prevent the sublimable solid from escaping out. For example, when we want to separate ammonium chloride from the common salt, separation of iodine from the sand. So here the mixture of iron and sand is taken into iodine and sand taken into this dish, and the inverted funnel or porcelain dish, this one, and this is covered with a cotton plug. When we heat it, the sublimable substance that get evaporated and collected here. So when it cool down and condense, we will get that substance. Clear? Next, method of separation of solid liquid mixture. Sedimentation and decantation. The method is based upon the setting down of heavier insoluble particle in an insoluble solid liquid mixture on standing for some time. The insoluble solid components in the solid liquid mixture settle down on the standing in the beaker. This method is used to separate a solid liquid mixture which is insoluble. Clear? This is known as sedimentation. The liquid above is poured out in such a way that the solid remain behind is called decantation. So here the mixture is taken which contains solid and liquid mixture. The solid is insoluble in liquid. So we will let it settle down for some time. The solid will settle down at the bottom and then we pour out the liquid like this without the solid coming out, and the solid will remain behind, and this is how we can separate the solid and liquid. The settling down, this process is known as sedimentation, and when we pour out water from that, this process is known as decantation. This is how we can separate a solid and a liquid. For example, separation of sand and water from the sand-water mixture, separation of impurities in the drinking water using alum, separation of tea leaves from the tea by decantation. Next is loading. Loading is a process in which chemical substance like alum is added to the solid liquid mixture to settle down the solid particle quickly, because alum increases the rate of sedimentation. So alum is mixed into mixture so that the solid particle quickly settle down at the bottom. Alum form the crust of clay particle and make them heavy. It helps to them settle down faster and increase the rate of sedimentation. For example, separation of clay and mud from the muddy water can be done by using this technique. Clear? So here, beaker A, water and sand mixture, muddy water will mix alum into it. It will increase the rate of sedimentation and the impurities will settle down in the beaker, and this is clear water. Clear? Next is evaporation. The process during which liquid change into vapor on heating below the boiling point is called evaporation. Evaporation is the process of changing liquid into vapor on heating. The method is based on changing the liquid component into the vapor by heating a homogeneous solid liquid mixture. The soluble solid, like salt from the salt solution, can be separated by heating on that liquid component. Water is lost and the atmosphere and the salt remain behind. So here the mixture that contain common salt and water, when we heat it, the water get evaporated and the common salt left behind. This is how we can separate them. Clear? Example, separation of sugar from the sugar solution, evaporation of salt from the seawater. These are the examples. Next, filtration. The process of separating insoluble solid particle from the solid liquid mixture by passing it through a filter is called filtration. Filtration technique is based on the separation of insoluble solid substance from the solid liquid mixture using the filter paper. This is a filter paper. We'll fold it, first fold, second fold, and we'll make a cone of filter paper like this, and we'll put it in a funnel, and then we'll separate the solid and liquid by filtering it. The filter paper make into cone and placed into funnel or strainer. On pouring the mixture of insoluble solid and liquid into the funnel, the solid particle remain on the filter paper. So the solid particle will remain on the filter paper and water will collect it below. Clear? While liquid collected below. The clean liquid is called filtrate, and the insoluble solid particle that remain on the filter paper is called residue. Means जो ऊपर बच जाएगा, that is called residue, and the liquid will collect below. Example, separation of mud from the muddy water, sand from the sand, and water, tea leaves and tea, etc. These are the example in which we use the technique of filtration. Like here, water and sand mixture. This is a glass rod. We'll pour the water, and here the filter paper is placed in the funnel, and we'll filter it. The clear liquid will collect below, and insoluble solid or residue will collect on the filter paper. Clear? Next is presence of particular technique over another. नहीं, वापस preference है. Next is preference of particular technique over another. Out of all above mentioned technique, filtration is much better and sensitive approach for separation for the mixture of solid and liquid, because it can be used to separate even smaller solid particle present in the form of impurities which may not be completely settled down with the sedimentation. At the same time, during the decantation, there is a chance of the particle mixing back into the liquid. So filtration is a technique that can overcome this. So to avoid all these things, we can use the technique of filtration over the decantation and sedimentation. The filtration is better than sedimentation and decantation. Next, you will do all these questions. So we'll do remember points to Next are some important points to remember. Matter can be classified into element, compound and mixture on the basis of their chemical constitution. Elements are pure substance which cannot be split into two or more simpler substance. Element can be classified into metal and non-metal, metalloid and noble gases. Element are represented by the symbol and they have placed in periodic table. Metallic element are placed in the left and non-metallic element are placed on the right side of periodic table. All noble gases are placed on the extreme right of the periodic table. Compounds are the pure substance that are made up of two or more elements combined in a fixed ratio by mass. Compound are represented by a formula. Mixture are impure substance which are made up of two or more elements or compound mechanically mixed in any proportion. Mixture may be either homogeneous or heterogeneous. Mixture can be separated by physical method, hand picking, sieving, sedimentation and decantation, loading, filtration, sublimation. Evaporation and magnetic separation are different methods used for separating mixture. Winnowing is used by farmer to remove the husk from the grain. Sieving is the process in which the mixture are passed through the porous medium. Magnetic separation is used for separating the magnetic component from the non-magnetic component. Sedimentation and decantation is used for the heterogeneous mixture of solid and liquid where the solid component is insoluble and heavier than the liquid component. The process in which external agent is added to bring about the sedimentation is known as loading. Filtration is used to separate lighter and insoluble solid particle from the liquid through the filter. Evaporation is used to separate the components of the homogeneous solid liquid mixture by heating below a boiling point. Sublimation is used to separate sublimate substance like ammonium chloride from the non-sublimate substance like sand and common salt, etc. Here is a mind map. Element, compound and mixture. Element, they are made up of one kind of atom only, like metals, sodium, iron, copper, etc. Non-metal like carbon, oxygen and fluorine. Metalloid like boron and silicon. Compounds made up of two or more elements in a fixed ratio. Organic made up of carbon. Inorganic made of element of other than carbon. Organic compound, they are entirely made up of carbon. Inorganic, they are the element other than carbon. Next, mixture. Mixture are made up of two or more elements in indefinite amount. It can be classified into homogeneous mixture and heterogeneous mixture. Homogeneous mixture, alcohol and water. Heterogeneous, kerosene, oil and water. So, this is the end of chapter. I hope you understand it well. Now you have to revise it properly and do all the questions. Clear?